Hey guys, welcome back to the channel, and in this video I'm going to show you where the quadratic formula comes from. So we start with the general equation of a quadratic, ax squared plus bx plus c is equal to 0. And in order to derive the formula, we're going to need to complete the square on this equation. So as always, the first step is going to be to factorize the coefficient of x squared, which is a, from the x squared term and the x term. So that will give us a x squared plus b over a x plus c is equal to 0, and that will allow us now to complete the square on these two terms here. So we know that we can rearrange x squared plus b over a x into the form x plus half the coefficient of x, so half of b over a, which is b over 2a squared minus b over 2a squared. And now that we have this equivalence, we can replace x squared plus b over a x with what we have on the right hand side. So that would give us a x plus b over 2a squared minus b over 2a squared plus c is equal to 0. And notice how the square brackets here ensure that the a is distributed to both the terms inside the pair of brackets. So now that we've completed the square, all we need to do now is make x the subject of this equation. So we're going to need to rearrange all of this so that x is on the left hand side and everything else is on the right hand side. So we can start by taking c away from both sides, and that will give us a x plus b over 2a squared minus b over 2a squared is equal to minus c. So I've copied our last line of working onto a new page, and our next step will be to divide both sides by a, so that on the left the a's are going to cancel, and on the right we're going to be left with minus c over a. So we're going to end up with x plus b over 2a squared minus b over 2a squared is equal to minus c over a. And again, all we're trying to do is isolate the x on the left hand side and shove everything else on the right hand side. So it makes sense to add b over 2a squared to both sides here. So on the left, these are going to cancel, leaving us with x plus b over 2a squared is equal to minus c over a plus b squared over 4a squared. So I've just expanded the brackets of this term here, so that now we can look for a common denominator for these terms so that we can combine them into one fraction. So we see that the common denominator is going to be 4a squared. So if we multiply both the top and bottom of this fraction by 4a, then that will give us minus 4ac over 4a squared plus b squared over 4a squared. Then we begin to see familiar letters b squared minus 4ac, which is a promising sign. So we've now shown that x plus b over 2a squared is equal to b squared minus 4ac all over 4a squared. And at this point we can square root both sides so that on the left the square is going to cancel the square root, and on the right we're going to have a positive and negative square root. We know from our third laws that root a over b is equal to root a over root b, and so therefore we can simplify the right hand side here as plus or minus the square root of b squared minus 4ac all over 2a, because the square root of 4s squared is 2a. So that will give us x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac all over 2a. And so our last step is to subtract b over 2a from both sides. And at long last we've reached the quadratic formula x equals minus b plus or minus the square root of b squared minus 4ac all over 2a.